Hello students, in this lesson we're going to be doing the Ohm's Law lesson on Tinkercad. So go to tinkercad.com/learn/circuit/lessons. Make sure you're on this page so that you can see the Ohm's Law link, the page that you have to click. So I'm going to go ahead and click on that and we're going to get started. Okay, let me reset mine. Alright, Ohm's Law. In this tutorial, we'll learn about a fundamental concept in circuit design known as Ohm's Law and apply it to ensure that we can safely light up an LED. This is Ohm's Law. This is a formula that helps us calculate for voltage, current, and resistance. And we're going to be learning how to use this and calculate for all three of those things throughout the course. Click on Next. In all circuits, electricity flows from the positive side of your power source, like a battery, to the negative side. The name for the flow of electricity is called current. So the flow of electricity is current. When current flows through a component, or components like an LED or a resistor, there is an associated change in potential energy across the component that is known as voltage. The amount of voltage drop across the component depends on the resistance or how much it restricts the flow of current. This can be really important for making sure your components don't fry because they aren't able to support the current coming from your battery, as we will soon see when it comes to parts like LEDs. These three concepts, current, voltage, and resistance, are all related to one another through a law called Ohm's Law, where voltage is equal to the product of current and resistance. So voltage is equal to current times resistance, or V equals IR. Okay, so we're going to test this out. Next. So we have this simple LED circuit. In the editor, you'll find a simple circuit connecting an LED 9-volt an LED directly to a 9-volt battery. If we power the circuit, we expect that current will flow from the positive side of the battery through the LED and then into the negative side of the battery. Turn on the simulator to see what will happen with our LED. Hover over the LED to reveal a message about the amount of current flow through the LED. Let's click on Start and look what happens. So if we put our mouse over it, it says current through the LED is 915 milliamps, while absolute maximum is 20 milliamps. So that means that there's too much current flowing through the LED with the current design. This could really damage your LED. Let's see how we can prevent this from happening in the next step. Next. Stopping simulation. Now let's apply Ohm's Law. In the last step, you saw how there was too much current flowing through the LED. Let's recall Ohm's Law, where voltage is equal to current multiplied by resistance, V equals IR. LEDs have a maximum rated current level, or a maximum amount of current it can safely handle. So this LED has a rating, and we should know how much current it can handle. In this case, let's account for a maximum current of 20 milliamps, a fairly standard rating for LEDs. That's a 0.02 amp if we convert milliamps to amps. We'll learn more about that later. If we want to ensure that there is only 20 milliamps of current flowing through the LED, we will need to add some resistance to our circuit. We know that voltage is 9 volts because of the battery. We're using a 9-volt battery. So if we apply Ohm's Law, we have 9 volts divided by 0.02 amps, which is equal to 450 ohms. Ohms is our unit for resistance. So what we did here is we took the information that we knew the volts and we knew the amperage. We changed the formula of V equals IR to V divided by I to get the R, which is the resistance. I think I said that right. So ohms is our unit for resistance. Yes, I did say that. This means that if we want to ensure there's only 20 milliamps of current flowing through the LED, we want to add a resistor with a value of 450 ohms to our circuit. So let's do that. Let's click on resistor, bring that in, and then change this to ohms and type 450. We're going to click on the red wire and delete that. Press delete on your keyboard. Put that there and then wire that up, changing that to a red. There we go. So we added the resistor. We changed the value to 450 ohms by changing that here once we click it. And then we're going to continue to the next step. So congrats, you learned how to apply Ohm's law to limit the amount of current through the LED. So if we click on start, the LED will turn on and it will not fry, it will not burst. In a circuit in which there is a single path for current to flow like this one, the current through each element for the circuit will be the same. For this reason, it actually doesn't matter where the resistor comes before or after the LED. Either way, it will limit current flow. You can test this out for yourself if you'd like to place the resistor between the cathode's this part, and the battery. Okay, so if you want to try that, we're going to move that out of here, delete that, and we're going to delete that, put the resistor here, and go to the cathode, and then go to the anode, and then start. There you go. So did you notice how the color bands of the resistor change when you edited its resistance value to 470 ohms? Oh wait, we didn't do that part yet. If I change it, so look at the color bands. Let's zoom in. So resistors, they all have a color band code. So depending on the amount of resistance, you can change. You change the resistance number here, and you can see the actual color bands changing. So in our electronics kits, we have 330 ohm, and you can see how that matches. And so color bands on the resistors are used to visually determine its value. And there is a link here that talks about the color code of resistance. Let's go back. Okay, so we did, go back. Oh no, what's happening? Okay, so once you have your congratulations and you're done with the lesson, take a screenshot the whole screen and submit it in the Google Classroom assignment for Ohm's law.